longevity. As we age, those stem cells don't function as effectively. Speaking of things that might make you rethink your snack choices,
to treat serious infections and to determine if there are any risks. It's not suitable for everyone, even if you're healthy.
We need to ensure these treatments are affordable.
It's not just about finances. We need to address underlying social and economic factors that influence health.
Hey everyone, ready for a deep dive into some out there ideas about living longer?
I'm ready. Gonna be fun.
Today, we're tackling longevity. Not just eating veggies and hitting the gym, we're going deep into the science that might rewrite the rules of aging.
I like where this is going.
You sent me fascinating articles about unconventional paths to a longer life, fasting, fecal transplants, and even intriguing research surrounding blood transfusions from younger individuals.
Blood transfusions? Sounds like a movie.
Right. I know it sounds unusual, but there's intriguing research behind these ideas.
Yeah. Let's kick things off with fasting. I've heard a lot about the potential health benefits, but I'm still a bit fuzzy on the science.
Sure. Well, one of the studies you sent over, the one from MIT, looked at the impact of fasting on mice. The results were mind-blowing.
What did they find?
They found that a 24-hour fast, just one day of not eating, dramatically boosted the regenerative capacity of intestinal stem cells in mice.
Okay. Intestinal stem cells.
These stem cells are basically the workhorses of your gut. They're responsible for maintaining that lining, which is super important for overall health and immunity. As we age, those stem cells don't function as effectively.
Fasting supercharges stem cells.
You got it. Fasting seems to trigger a metabolic shift in the cells. They shift from using glucose to breaking down fatty acids.
It's like flipping a switch in how cells fuel themselves.
Exactly, and that flip triggers a cascade of molecular events that actually enhance the cell's ability to regenerate.
Okay, that's amazing for mice guts, but what does that mean for humans?
There's growing evidence that fasting could have similar effects on other cells in the body.
So it's not just about gut health. It's about slowing down aging throughout the whole body.
That's the idea. And get this, in the MIT study, they were even able to replicate the effects of fasting by giving the mice a drug that activated a specific molecular pathway.
Wait, so there could be a fasting pill someday?
That's wild.
It's early days, but the possibility is there.
But let's talk about actual humans for a minute. What about that study from Kyoto and Okinawa, the one with the volunteers who fasted?
Ah, yes. That one's fascinating. It shows fasting can cause significant changes in our metabolism.
Changes?
They found that during prolonged fasting, there is a significant increase in something called ophthalmic acid.
Ophthalmic acid. Is that something to do with your eyes?
It's found throughout the body. Ophthalmic acid is important for protecting cells from damage.
So the more ophthalmic acid you have, the better your cells are protected.
That's the gist. Levels of ophthalmic acid naturally decline as we age, but guess what?
Fasting brings them back.
Bingo.
It's a natural anti-aging molecule that our bodies already produce, and fasting just gives it a boost.
Precisely.
Wow. I'm starting to see why people are into fasting. But before I sign up for a week-long juice cleanse, what about that study with the tiny worms, the C. elegans? The one where they mess with their diet?
Ah, yes, the nematodes. So those little guys might seem kind of unusual, but they're incredibly useful for studying aging.
Their lifespan is only a couple of weeks, which means researchers can observe their entire aging process in a very short amount of time.
It's like fast-forwarding through aging.
In the study from Harvard, they restricted the worms' diet. Basically, they put them on a calorie-restricted diet, and you know what?
It had this huge impact on their mitochondria.
Mitochondria. They're the powerhouses of the cell.
They're the tiny energy factories inside every cell.
What happened to the worms' mitochondria when they went on a diet?
As we age, our mitochondria fragment and break down. They become less efficient. Researchers found worms on the calorie-restricted diet maintained their mitochondria in a more youthful, interconnected state,
Keeping those cellular power plants humming smoothly longer.
This mitochondrial preservation was directly linked to the worms living longer.
Even those tiny worms, cutting back on what they ate, made a difference in how long they lived.
Remarkable, right?
Okay, we've got mice, humans, and tiny worms all showing that fasting, or even just mimicking its effects, can have some pretty powerful anti-aging effects.
That's a lot to digest.
It's a recurring theme in longevity research. Fasting seems to trigger some ancient survival mechanisms that we've kind of forgotten about in our modern world of abundance.
Makes you think twice about that late night snack, doesn't it?
Speaking of things that might make you rethink your snack choices, are you ready to dive into the world of fecal transplants?
Oh boy, here we go. This one's a little hard to stomach, literally.
Yeah.
But hey, for science.
Science.
Tell me about this Max Planck Institute study. They gave gut microbes from young fish to middle-aged ones. Did anything happen?
Well, get this. The middle-aged fish who received those youthful gut microbes actually lived 37% longer.
That's like adding decades to a human life.
Whoa, that's a huge jump. Are you telling me the secret to a longer life is in someone else's gut?
The research suggests the gut microbiome plays a bigger role in aging than we realized. Giving younger fish microbes to older fish had no effect.
So it's not just about having any bacteria in your gut, it's about that youthful balance. How does this translate to humans?
Right. Well, there's growing evidence that the gut microbiome plays a similarly important role in human aging.
There was this study from Canada. They conducted fecal transplants on mice, focusing on structures in the small intestine called Peyer's patches.
Peyer's patches. Well, that doesn't ring a bell. What are those?
Think of them like immune system outposts in your gut. Clusters of immune cells that protect you from harmful substances.
They're like security guards for your gut.
Yeah, that's a good way to put it. As we age, these Peyer's patches begin to decline, making us more vulnerable to infections and age health problems.
Our immune system gets weaker in our gut as we get older.
Fecal transplants from younger mice could rejuvenate those Peyer's patches in older mice.
Wow, so it's like giving them a dose of youthful immunity. Pretty much. Okay, that's kind of blowing my mind. We've got fish and mice showing gut bacteria can influence lifespan.
Are people actually doing fecal transplants right now?
Fecal transplants have been used successfully to treat serious infections. Cure rates are over 90% in some cases.
Wow, I had no idea. But I gotta admit, the thought of it is still kind of,
Yeah, I get it. It's not the most appealing procedure. If it works, and maybe someday we'll have more refined methods of delivering beneficial gut microbes.
Fingers crossed. Okay, before we move on, there's one more longevity path to explore, and this one sounds straight out of a horror movie.
Young blood transfusions. Are we talking about vampire science here?
Research in this area is pretty wild. We actually have multiple studies that show some pretty remarkable effects of younger individuals' blood on older mice.
Is there any actual evidence that younger individuals' blood can make older bodies younger?
One study from UC and Stanford found infusions of younger individuals' blood improved brain function in older mice. Like their memory got better. And they even started forming new connections between nerve cells.
Wow, that's not just physical rejuvenation, it's a brain boost too.
Yeah, one of the researchers who worked on that study, Rudolf Tanzi, a prominent figure in genetics and aging, stated he was amazed by how much younger the mice became, both physically and mentally.
Wow, amazed. That's a strong reaction. Did the younger individual's blood boost brain power? What about other parts of the body?
Oh yeah, another study from Harvard found younger individuals' blood rejuvenated muscles in older mice.
They became stronger and had more endurance, and they even identified a specific protein in younger individuals' blood, GDF11, that appears to be responsible for muscle regeneration.
Ooh, gotta remember that one. So it's like a muscle-building elixir found in younger individuals' blood?
Seems that way.
And then that Harvard study showed younger individuals' blood improved the sense of smell in older mice, right? And circulation too.
It's amazing that blood could have such a powerful impact on so many parts of the body.
It makes you wonder, what else is hiding in that younger individual's blood?
What other secrets are we going to uncover?
Are we really talking about vampire-style blood transfusions becoming a thing in the future?
Hold your horses. It's not that simple. The studies in mice are exciting, but we've got a long way to go before we can safely try this in humans.
Safety first.
We need those large, rigorous clinical trials to ensure it's actually beneficial and to determine if there are any risks.
We're not scheduling younger individuals' blood transfusions yet, but the potential is there.
Oh, absolutely. It raises some significant ethical questions, too.
Who would have access to these treatments if they become a reality? And what would it mean for our healthcare systems?
It's a new world of possibilities and challenges.
We've covered a lot today, from fasting to fecal transplants to younger individuals' blood transfusions.
What are your big takeaways? What's sticking with you?
What strikes me is that all three of these approaches, as different as they seem, tap into these ancient, almost primal.
We're rediscovering hidden powers we've forgotten about.
That's it. Exactly.
While the research is still in its early stages, we're only just beginning to understand the true potential.
This has been an amazing conversation. I'm thinking about my gut health and maybe giving that 24-hour fast a try. But for now, let's take a break and we'll come back and explore some of the ethical and societal implications of extending lifespan.
I'm ready for round two. Yeah.
All right, we've delved into the science behind longevity ideas, fasting, fecal transplants, and younger individuals' blood transfusions. But now let's shift gears and talk about the bigger picture. What are the implications?
That's a really important question.
It's not just about whether we can extend lifespan, but whether we should. And if we do, how do we do it responsibly?
What worries you about all of this? What are some potential challenges or concerns we need to be thinking about?
One major concern is unintended consequences. We're still learning about aging.
Interfering with these processes could have unforeseen repercussions.
Yeah, it's a domino effect, right? You change one thing and who knows what else might get thrown off balance.
That's it exactly. For instance, let's take fasting. It's shown some great results, but it's not suitable for everyone. Even if you're healthy, doing it the wrong way could be risky.
Yeah, that makes sense. Any powerful tool, you got to know how to use it correctly. What about fecal transplants? Any risks?
Absolutely. They've been effective for certain infections, but altering the gut microbiome is serious. We don't fully understand the long-term effects yet.
Right. It's not just swapping bad bacteria for good. It's a whole ecosystem.
Gut microbiome is incredibly complex and connected to many aspects of our health. Modifying it could have ripple effects throughout the body.
More research is needed on that front.
Let's talk about younger individuals' blood transfusions. That one seems most ethically tricky. What do you say?
Oh, yeah, for sure. There are so many ethical dilemmas. A major one is exploitation. What if younger individuals' blood becomes extremely valuable? There's a risk people could be exploited for their blood, especially those who are already vulnerable.
Ugh, that's a frightening thought. We don't want to create a world where the wealthy are exploiting the youth of the less fortunate.
We must ensure that any advancements in longevity are accessible to all, not just a privileged few.
Access and equity are significant concerns. What other ethical challenges come to mind?
When you think about younger individuals' blood transfusions,
Informed consent is another crucial aspect. Individuals need to fully understand all potential risks and benefits before donating or receiving younger individuals' blood. And they need to be able to decline without feeling pressured.
it's their body, their choice.
And then there's the psychological impact to consider. How would people cope with living much longer? Would it alter our views on work, family, retirement, and how we live our lives?
That's a good point. Are we emotionally and mentally prepared for such a substantial shift in lifespan?
It's mind-blowing to think about.
It truly is. Then you've got societal implications. What happens to healthcare systems, retirement plans, even just our cities and infrastructure if people are living decades longer?
Extending lifespan could drastically change everything.
Exactly. More people living longer means more resources consumed, more waste produced. A lot to consider.
We need to pump the brakes and carefully consider this before extending lifespan.
I agree. We need to be cautious, thoughtful, and think through the potential consequences.
How do we move forward responsibly? What are some concrete steps we can take to mitigate these risks and ensure that any longevity advancements benefit humanity?
First, we need more research. We've learned a great deal, but we still have much more to uncover about aging.
It's not just about finding a magic pill, it's about understanding how all the pieces fit together.
Exactly. We need to continue investing in fundamental science, in discovering exactly how these interventions function and what the long-term effects are.
Research is key.
We need open and honest discussions about the ethical aspects of all this. That means scientists, ethicists, policymakers, everyone needs to be involved.
It's a global discussion about the future of aging, right?
Exactly. We need to initiate those conversations now.
Before these technologies become widely available, we need to establish some Ground rules, some ethical guidelines to ensure we're using them for the betterment of humanity.
It's about our values as a society.
Exactly. We need to determine what kind of future we're striving to create.
What about the practical aspects? How do we ensure these longevity interventions are accessible and affordable for everyone, not just the wealthy?
That's crucial. We need to make sure our healthcare systems are prepared for a potential surge in lifespan. That means increased investment in geriatric care, new approaches to caring for an aging population.
It's not just about living longer. It's about making those extra years good years, right?
Absolutely. We need to ensure people have access to quality healthcare, social support, and opportunities to remain engaged and active.
Yeah, we don't want to create a world where people are living longer but miserable.
Now, what about the whole inequality issue? How do we prevent these longevity interventions from becoming just another luxury for the rich?
That's a major concern. We need to ensure these treatments are affordable. Perhaps that involves government subsidies, public-private partnerships, or open-source research models.
We need to be creative.
It sounds like we need a completely new approach to healthcare, one that prioritizes equity and access for all.
Exactly. It's not just about finances. We need to address underlying social and economic factors that influence health, such as access to education, housing, and nutritious food.
It's about creating a world where everyone has the opportunity to live a long, healthy, fulfilling life.
It's about shifting focus from extending lifespan to promoting healthy aging for everyone.
Instead of just adding years to life, we're adding life to years.
Beautifully put, that's precisely what we should be striving for. A world where everyone can thrive throughout their lifespan.
Well, this conversation has demonstrated how complex longevity is. It's not just about the science. It's about our values, ethics, and vision for the future.
I couldn't agree more. It's a conversation we all need to be a part of.
To all our listeners, thank you for joining us on this deep dive into longevity. We hope it sparked your curiosity about the future of aging. Continue exploring, keep asking questions, and keep dreaming big. The future of aging is in our hands. Let's make it a positive one. Until next time, stay curious and keep exploring.